Hi, my name is Neeraj, and in earlier videos we have understood about byte data type. So in this video we will understand why masking is required during data type promoting. So we will understand this with code example. So here we will take one byte variable b and we will assign byte, let's say 0xc8. So c8 will have if we talk about decimal integer, so c8 is 0x8. 0x here it means that we are assigning hex values. So the decimal representation of this same hex value will be -56, and when it will be converted to the unsigned, so unsigned value will be 200, correct? So next I want to promote these byte data type to short. I want to store the same values because C8 is -56 and it is just beyond the positive values, right? So when we do that, when we store these values to short, so basically we are doing here is data type promoting. Okay, so this is called promoting data type. Okay, so before understanding why masking with ff is required here in promoting data type, so let's first print out the decimal and hexadecimal values of short and byte variable. Okay, so system out byte value, so this will print the decimal integer values. For to print the hex value, we will use string.format method. Okay, so this will print the decimal integer values of byte and short variable, and this will print the hexadecimal integer value of byte and short variables respectively. Okay, so let's just print out and see what is the result. So as you can see, these are decimal integer values of the same, and these are hexadecimal integer values. So as you can see, here short value preserve the sign bit here. Sign, it's copy the same values including the sign. Okay, and here is in case of hexadecimal value it has a C8, and in short variable value it has FFC8. In case if we don't want FFC8, and in case if we want only unsigned value to get a store inside the short variable, so on that case masking with FF is required during promoting data type. Okay, so let's see how it is done. So here what we have to do is we have to perform AND operation with 0xFF. Okay, and we have to cast it with the short data type. Hence we are storing these values to the short variable, so casting it with the short is required. Okay, because the resultant value of this operation are unknown, so so it is important to cast it with the short value. Okay, so here B, I have performed AND operation with FF. So as you can see, B here also it is promoting data type, right? Because here while performing AND operation with 0xFF, here it is here it is actually promoting data type with the integer, so it is implicitly getting casted with the integer values. Okay, because here Java compiler implicitly casting here with the integer value, so we are not getting any error while in this operation. So in case if we use Java Cut framework on their these integer value are not supported, integer data type not supported, so there you can get the error if we do not cast the appropriate with the appropriate data type. Okay, so let's cast it with short. Okay, so here you have choice whether you have to cast it or not, because compiler automatically cast this with B with the integer data type. Okay, so I am choosing to cast it with the short. Okay, right, just follow the rule. Okay, so we have done the masking, and let's see the result. Okay, as you can see the result are there. So short variable has unsigned values, not the negative integer. Okay, so here in this case we have short variable has unsigned values 200. Okay, so that's the thing. And when talk about hexadecimal value, so byte has C8 and short variable earlier it was FF8 and now it has C8. Okay, so this masking with FF works here. So if there is a requirement of this, so we can use masking. Okay, right. So so how this masking actually work? Why we need to only mask with 0xFF, not with the other hexadecimal value, and how this masking actually work? Okay, so let's understand deeply about that. Okay, so why masking with FF? So masking it with FF is required to avoid sign bit extension. Okay, or to make it unsigned, we mask variable with FF value. So what is sign bit extension? When promoting the data type as we did earlier, so promoting byte to short or short to long, Java copies the sign bit. Sign bit is what? Sign bit is the most significant bit, okay, into the high order bits to preserve the number values. Okay, the most significant bit of a signed number is the sign bit. Okay, 0 indicates positive and 1 indicates the negative. Okay, so here already we have seen the example. So byte variable b contains hexadecimal integer value c8. Okay, so here here this b has value hexadecimal c8 and negative decimal integer -56, and its corresponding binary number will be this. Okay, and you can see this first bit is this is MSB. Okay, so this bit indicates sign. Okay, so this is a sign bit. For byte data type, the 8th bit means the most significant bit. The 8th bit will be the sign bit. Okay, so this is the MSB, most significant bit. Okay, so this is a 1. Okay, that means the number will be negative. Okay, so while promoting, this is actually promoting. Okay, so while promoting, what happens actually, so short variable has 16 bits. Okay, so this sign bit get extended to the new high order bits of the short variable. Okay, so this sign bit will get copied to the rest of the new high order bit. Okay, and the remaining binary values will be this. So the resultant binary value will be FFC8. So these high order bits get enabled. That is why we are getting here FF, and these values become C8 and decimal integer value -56. So that is the reason we are getting values for the short variable FFC8, right? So because here it is getting sign bit extension. Okay, during promoting data type. Okay, so how we resolve this? So the only solution here is with masking with 0xFF or 0x00FF. Okay, so as you can see, B here B I have casted it with the explicitly casted it with short data type, means this value it will be, sign bit extension will be happen. Okay, so the resultant value will be here. Okay, because B is a short, I have explicitly casted, so total 16 bit will be there, and due to the sign bit extension, the higher order bits will get enabled. Okay, so the B variable values will be this, and now we are performing the AND operation with FF, or you can say 0x00FF, both are same. Okay, so we are performing the AND operation, or you can say masking with FF, hence the resultant value will be C8. Okay, so when we perform this 16 bit uh, binary values with the 0xff, the resultant will be value this. Okay, so high order bits will be 0, and we will get the result actual value. Okay, so this is how zero masking with 0xff really works. So that is the real explanation of how this masking works, to avoid the signed bit extension. Okay, or to make it unsigned, we mask variable with 0xff or 0x00ff. So from this I am ending my video. Hope you have understood how this masking work, or whenever you required to mask variable, so you can use it there. Still you feel if you have any doubt or query, so please feel free to comment in comment box, right? So for now, thank you very much. Bye.